Hello students. So this is a good question. Here they had given us that you are provided with a hollow iron ball A of volume 15 centimeter cube and mass 12 gram and a solid iron ball B of mass 12 gram. Both are placed on the surface of water contained in a large tub. So there are two balls. Both are made of iron, but ball A is hollow. It means its surface is made of iron, but inside the surface there is nothing or air is inside the surface. So it is hollow. So its volume is 15 centimeter cube and its mass is also 12 gram. Similarly, another ball is there, ball B, which is solid ball. It means it is completely made with iron. No air, nothing is inside it, only iron is there. So its mass is 12 gram. Okay. And both balls are placed on the surface of water in a tub. What we need to find out? We need to find out the upthrust on each ball and which ball will sink. Okay. And we need to give the reason for our answer as well. So density of iron we need to take as 8 gram per centimeter cube. Okay. So now we will start to solve this. So here in this question, ball A's volume is given and it is kept in water. So density of water is known to us. Okay. So first of all, we will find out what could be the maximum upthrust on the ball A. So maximum upthrust we can find out like when you completely immerse this ball A inside water. Okay. So we'll try to find out the maximum upthrust. Okay. So we can say upthrust on ball A when completely in water or completely immersed in water. So here we know that formula for upthrust is volume of the body, density of the liquid into G. So here we can find out our answer in gram force only. So we need not substitute the value of G. So here volume is, complete volume is 15 centimeter cube. So we are taking in CGS unit only. Mass is also given in gram. So here density of liquid is water. So that is 1 into G. So we can say upthrust is equal to 15 gram force. But here, since weight of ball A is 12 gram force, okay, 12 gram is the mass, so weight will be 12 gram force, which is less than upthrust on complete immersion. It means when the body is completely immersed, okay, then upthrust acting would be 15 gram force. But since weight is less than this value, it means the downward force, weight is 12 gram force and the upward force is 15 gram force. So it means the resultant force on the ball will be in upward direction. So the ball will not remain inside water. It will come up such that the upthrust acting on the ball balances the weight of the ball. It means the ball will float. So we can say the ball A will float. Okay. So in case of floating, when a body is floating, then upthrust acting, upthrust acting will be equal to its weight. Okay. So here the upthrust on A we can write upthrust on A will be equal to weight, that is 12 gram force. Okay. So note down this. This is the first part of the A part. Like question number A is to find upthrust on each ball. Okay. So here we have calculated only for ball A. Okay. And yes, we had also solved the part B and reason for this ball A. So we can say the upthrust on ball A will be 12 gram force. So let's summarize for the ball A first and then we will solve for ball B. So here the ball A is an hollow iron ball. Okay, its volume is 15 centimeter cube and mass is 12 gram force. So its mass is 12 gram force means its mass is 12 gram. So its weight will be 12 gram force. Okay. Now, suppose you have completely immersed this ball A inside the water. So in that case, the upthrust acting on ball A would be the maximum upthrust. So this maximum upthrust we can calculate by using the formula volume of the ball inside the water into density of water into G. So when you calculate this, it will be 15 gram force. So 15 gram force is the maximum upthrust that can be acting on ball A. But since the weight of ball A is 12 gram force, which is less than the maximum upthrust, so what will happen? The resultant force on ball A will be in upward direction. So ball A will come up, okay, and it will remain in the floating state at the surface of the water, such that some volume will be inside the volume and only that much volume will remain inside water, that upthrust due to that submerged part should be balancing weight. It means the body will float. For example, if I am making a diagram, so here the ball A will be somewhat like this. So it's some part, okay, will remain inside water. Only that much part whose upthrust is equal to 12 gram force and which is balancing weight. Okay. So some part will remain inside water, remaining will remain outside water. So this is the case of flotation. Whenever a body is floating, in that case, the upthrust acting on that object is equal to its weight. Because when the body is floating means the resultant force acting on it is zero. So here, whatever downward force is acting, the upward force or upthrust should balance that force. So here downward force is equal to weight, that is 12 gram force. So upthrust on ball A should also be 12 gram force. Okay. So this is the solution for the ball A. Okay. Note down the solution. Now we can see what will happen to ball B. So here you need to find upthrust on ball B. So for example, we are considering again the same thing, that ball B is completely immersed in water. So upthrust on ball B when completely in water or completely immersed in water. So again formula will be same, volume inside into density of liquid into G. So volume inside. So here volume is not given, but they had given mass and density. So we can write volume as mass by density. So mass is 12 gram divided by density is 8 gram per centimeter cube. So volume we can write 12 by 8. Density of water is 1 into G. When you solve this, 12 by 8 will be 1.5 gram force. This is the upthrust acting. Okay. But here, weight of ball B is also 12 gram force, which is greater than upthrust or maximum upthrust, that is 1.5 GF. So since downward force is greater than upward force, so we can say ball B will sink to the bottom. Ball B will sink to the bottom. Okay. So you can see a hollow ball will float and the solid ball will sink to the bottom. Okay. So this is very simple question. Only you need to compare for both of the balls. Okay. So that's all in this question.